There are three things to consider when doing performance management in the cloud: elastic resources, cost, and the shared responsibility model. Your cloud provider offers elastic availability of resources to increase and decrease performance levels. Users can grow or shrink deployed resources on demand in a timely manner to meet service levels. Costs are tied to deployed resources. And when it comes to the shared responsibility model, the user's responsibility is to optimize the balance of capacity and costs by implementing with the tools provided by the cloud provider. As a cloud provider, Amazon offers you a series of tools that you can use in your performance management process. For example, compute instance choices. You can choose among on-demand, spot, or reserved instances. Auto-scaling. You can program your structure to add instances when a utilization threshold is met, and you can sell back your reserved instances in a secondary market. These tools are easy to deploy, but difficult to use optimally, especially if you have a large number of resources deployed. Amazon provides no aggregated or summarized view. Also, Amazon provides no recommendations to optimize usage. You're basically on your own to figure it all out. Understanding your trade-offs is key for performance management. Deploying more resources reflects trade-off. Deploying more availability, more performance, and more security means more cost. Deploying fewer resources also reflects trade-off. Less performance, less availability, less security means potential poor customer experience. For example, outages, poor performance, or exploited vulnerabilities. Cloud customers need to find balance, meeting requirements around availability, performance, and security with cost of those resources. Ultimately, they need to meet end-user customer expectations within budget constraints. You need the actual usage data to make informed trade-off decisions. For example, take operation performance in your compute footprint. Newvem analyzes your entire usage pattern with a more sophisticated calculation which your cloud provider doesn't offer. They usually only provide the raw data. It then makes recommendations. What type of reservation you should buy or deallocate, and why? What levels of performance capacity should you bring online? Capacity reduction with smaller or cheaper machines, or capacity increase with bigger or more machines based on needs? Another example is the proper configuration of auto-scaling. Newvem provides the data that helps you configure your auto-scaling and assures proactive elastic behavior by tying your capacity to your service level needs. Another important aspect in your operation performance is your storage footprint. Newvem helps users decide between Amazon's storage management offerings, such as S3 standard storage, that provides faster retrieval times but is more expensive, RRS, reduced redundancy storage, that is slowly in its retrieval times and less expensive, and Glacier, that has longer retrieval times but is even less expensive. Users may need files at different levels of availability. Newvem also gives a perspective on the stored files within S3. What are the file types, their age, the redundancy type, and when they were last accessed. When users understand what they have in S3, they can decide what kind of service they want. For example, they may want to archive certain files from S3 to Glacier, taking them offline to save money. They also can find that they have redundant storage of files, and then remove the files either from S3 or from Glacier. Newvem provides understanding about balancing retrieval times versus costs. Newvem helps you understand your trade-offs when doing performance management in the cloud.